Hello everyone and welcome again in this tutorial. In this tutorial we will learn something quite new. Actually, it's not really new, but might be new for some of you. Today we will learn and we will look on how to debug your code. Okay, for example, if you have some code, then what is the methods that's been used to debug and what is the most efficient way to debug your code. Okay. So usually there are, let's say, I don't want to make it complicated for you guys, but I want to say there are two main ways to debug your code. Okay, so the first way is by software part or the hardware part. Okay, so the hardware part, usually I will use some pinout from the MCU itself or from my circuit. I'll use some pinout to trigger the pin high or low depending on the code situation. Then I will measure this timing or time it using the oscilloscope to debug my code. For example, let's go here to open some example and talk about it. Let's say we go with blink. Okay, so for example, this blink is very straightforward example. It just we define a pinout that's been connected to an LED. We define it as output. Then we just trigger it high and low at each second, which is 1 Hertz. Okay, so from here I can debug this. For example, my LED doesn't work, or for example, if I have very complicated code and I need to see something. For example, here I have some very long code. Okay, here is my very long code. Okay, and I want to debug this code. I want to see like how long it takes or what happens in between. So I can trigger this pin before and after, then I timing using oscilloscope. Or let's say I have a function here. Okay, function start from here to here, and I want to see whether my code sorry, not function, let's say if condition, and I want to see there's a condition here. I want to see if my code is going into this if or no. Okay, then I can put digital write. Let's just copy this. Okay, digital write high, and then when it's finished, digital high, digital write low. So when this pin I detected from my oscilloscope is going high to low, then it means okay, it's already entering this if condition. Or even function also can actually, for example, from here I will call function A, but this one just for example, I mean, it's not the correct way to code it. Then let's say there's another function here, we call it function A. Okay, so I want to see if it's executed or not. Then I can just again send any signal to the outward from this function. Let's say any pin to bring it high or low, then I will detect it using oscilloscope or multimeter. Okay, and also again, if let's say I have my very long code, but I want to measure how long it takes, instead of I use timer, I can precisely using oscilloscope. Then I'm timing the signal width from high to low. Then because it will give me a signal. Okay, square signal like high, then it will consume some time because it's do the processing in my very long code. Then when it's go low, then I just time this period or the width of the signal to find the code width, but sorry, the code length or the code what they call timing. Okay, so but now the second way is using the software by mean of there's some debugging tool. Okay, for example, if you're using Python, actually it depends on your compiler. If it's, for example, Visual Basic or even C, I mean the PC-based compiler, you still have what they call debugger, or even if you work with the PIC for micro C, they also have a debugger in the environment, in the software environment. I mean, in the code editor, let's say, okay, yeah, code editor and compiler debugger, but for the Arduino, unfortunately, until now, we don't have a debugging this function. So we have to simulate the debugging by using a serial monitor. Serial monitor actually a very strong and useful function they provide us with, so we can use it to debug our code. Okay, so let's go back to our code and open it again. We don't want to save this. Let's go back to our blink. Okay, good. So this blink is very straightforward. It will just blink an LED that's connected to this pin, which is pin number I guess 13. Yeah, because we're using Uno now, so this is pin number 13. Okay. Now we want to debug, for example, the LED doesn't work or something else. For example, can you imagine if you have like few hundred up to 1,000 lines of code and you want to debug it? So you want to see at some lines, or like you expect this data to be, let's say 10, but you get only 5, or expect this temperature to go high by this much, but you didn't get it, or some reading is not really accurate as you expected, so you need to debug it. How we debug it? We display some information on the serial. Okay, so by doing this, we can get some feedback from our code and from our actual setup in the Arduino MCU, which is the Atmega. Okay, so let's get started. So first I will initialize the serial monitor here. So I will initialize the serial monitor, serial.begin. Define the power date, let's say 9600. Okay. Then from here, how to, let's say I want to debug, I want to see, is it really this this pin is going high and low or no? So after I set it to high, so I can read it back again, then I can say serial.print, serial.println, and I will print the state of this pin, which is, I believe, is a digital. Yes, digital read, and this one. Okay. But before that, let's add serial.print, let's say this is the first value. Okay, and then after it's go here to do the process, then it should go low. Sorry, it should go low. Then this is the second. Okay. So now if I upload my code, I already have, okay, Arduino. Let's upload it. Oh yeah, we need a. Okay, some code there then. Okay, updated. So if you see now, this is the first value and print is 1 as we expected. Okay, there's a 1 here, 0, 1, 0. Let's add some space so it will be much obvious and more readable. Okay, thank you. Okay, so oops, we forgot this one. Okay, let's upload. Here we go. So the first value is 1, second one 0, 1, 0. So this is correct what we expect. But if we see something like odd, for example, okay, 1, 1, not 1, 0. From 1 go to 1 again, go to 0, 0 to 0. I mean, there is some misbehave of our code. Then we can go and dig exactly and see where is the wrong we have did, or the code is not behaved as what we want. Okay, but this one actually is very straightforward and very simple code. Okay, very straightforward. It's about like less than 50 lines. Can you imagine if you have few hundreds or even thousand? I can share with you one of my code that I wrote to my client. Sorry, I cannot show you all. This is all what I can show you. Can you see it can go up to 1,100 something line, okay? And can you imagine all this code you need to, at one stage of your design, that you need to debug it, okay? You need to debug the code. So can you imagine that you will use a lot of serial monitors, a lot of serial monitors here and there, okay? And by the way, all these serial monitors actually will delay your code and take space of your code also, okay? These lines actually will delay. Why? Because when the code is running, when come to execute this, then come to execute this one, actually takes time to send the data through the RxTX pin on the MCU, send it to the UART, or send it to the FTDI converter, which is UART to SPF to the USB. Sorry, then the USB will send to the to the serial on your IDE environment, and the IDE send acknowledgement, okay, received. Then so it's really take long time and exhaust your memory. Okay, so if you can see here, this memory will be exhausted, because as long as you work with the embedded system, your memory will be very, very limited. Okay, so let's take, for example, now if I took out all the serial print, okay, compile it again, and let's see the size. Here we go. You see the size now. We are using 1918 bytes, okay, for the sketch of the from the program storage, and also we use 184 bytes of the dynamic memory for the variables. Now let's open the serial. Let's snapshot this one so we can compare. Okay. Now I already released all the serial.print. Here we go. You see now? This one, when I disable all the serial monitor, no serial, you see 1918. You see here 2400 of bytes. And for the variable, we use only 184. Here we use 250. Okay. Can you imagine if you have like 1,000 line, okay, with multiple serial.prints for debugging? Okay. So we can try. Let's add on more. I can add here also. Here, let's say set up function started. Setup function finished. Okay, Let's add here also. Loop function started, loop function finished. Let's compile it again and see how much it will cost us to use all these things. Wow, you see how it goes even higher now. Almost I can say it's double. Okay, they use the double the memory space, especially for the global variables. Okay, again, this one actually, if you keep this serial printing functions running on your code and you send it to your client, or you're still using on your code, actually it will first exhaust your memory. Second, it will delay your function, delay the speed of your code. Okay, will not be that responsive code anymore. But if you just want to debug it, it's okay, because this is not the release version, still under debugging stage. Again, you still can solve this issue. You say, okay, I can go and comment out all the serial print, I don't know what. But again, can you imagine if you have like few thousand of code, then you have to go and comment, I don't know how many serial monitors do you have already in your code. Okay, so this is not practical solution actually, to go and comment and uncomment every serial this function that's printing out all your serial. So I come out with an idea which is quite useful, and I've been using it for some time. Okay, this idea actually can help you with the headache of defining or activating and deactivating your this serial function that's been using for debugging. And again, sometimes, for example, here we have serial printing, it doesn't relate it to, for example, to the debug. For example, I have some serial print here. Is I really needed to, for example, send some data to my RF using serial, or send to my any other device also using using the UIArt, or so this one not easy. Then you have, if you come, for example, after some time, then you read your code again, you need to debug. You're not sure this actually serial.print, is it really you use it for debugging, or you want it, or actually you are using it for communication purpose for your data. So again, you still actually you can add some comment. For example, you can say this serial used for communication, and then you can say, but this serial used for debugging. But again, you have to go line, the issue is line by line, and you have to search for which one for debugging, and you comment and uncomment every single one of them. Okay, so instead of this, I have come out with some idea which is really useful. Okay, so the idea is, let's function setup here, we don't need it. Let's take out, delete all this one. Okay, the idea is we use something called text substitution. Text substitution, actually, I believe most of you guys, you know, or you heard about it. So we will use here, we will use, let's give you some example. Okay, for example, we use hash define, let's say motor 1, let's say 4, and also hash define LED LED 2 equal to, let's say, pin number 8, and hash define my sensor 3 on pin number A0. Okay, this text substitution, what does that mean? Okay, it's mean if later on, let's say I come to the setup, I will delete this so far, or keep this one. Actually, we delete this one. Okay, no need. For serial, we keep serial. This one we keep built-in. For example, here instead of use built-in, I will use the LED2, and also I will copy this for the motor one. Okay, this text substitution actually it will substitute, because now if we don't have these, okay, if we, let's say we comment out all this one, then we will compile. I'm sure the compiler C will be stopping us. They say, hey, this LED or not declare it. What is the LED? Okay, so instead of we using or redefining LED as integer, then now we will reserve integer for the LED to equal, let's say, to 8. This one, the compiler will be happy because now we already declared the LED. Now we come to the motor, again not declared. So instead of using this, and we already actually reserve one complete integer for this LED, which is just to hold number 8, we can use text substitution. Text substitution is mean the processor, when it comes to execute your code, it will substitute or replace every word you type in here with the predefined value. Okay, so for example, when it comes to the LED2, it will remember, okay, LED2 actually is already defined as equal to 8. When it comes to motor, motor actually is equal to 4, so it will replace this with 8. Replace this with 4, whatever data you are declaring here. So you see now, if we compile, it will be happy. Okay. So this text substitution is mean we substitute or replace any words that come in the code with the value we declare in the substitute this text substitution. Okay. So from here, then I can say, okay, here for my LED, you turn on the LED high. Then after my long code, you turn off my motor, and then I want to read the, oh sorry, no, let's say here I want to read my my sensor, the A0 sensor we declared just now. So I will say serial dot print line analog read, but you know what, let's make it a bit simpler. We will say float data or value. You have to like it. Okay, let's say sense data equal analog read from. Again, we will use the word we defined just now, sensor 3. We will not need to use A0 because, for example, if you're using this sensor for many places, no need to keep changing it. So just here, sensor 3. For example, if you want to read it again, okay, first, let's keep this one. We go another. Let's take this. We declare it up here. Okay, so now if let's say you want to read it again, and here print line sensor, okay, good. So let's say again we want to read it after you finish 1000, finish the delay, then you want to read it here again. If you want to read here again and you didn't declare the text substitution, let's say we are not declared text substitution here, but you use the name directly. Where is it? Read analog directly from A0. Then you have to change again A0. Let's say you change your sensor location from A0, then on the circuit, then the mechanical designer come to you, say, okay, I don't have space for this, you have to move it out on the other side. And then when you move it to the other side, then again, from your PCB board, you cannot route out this A0 to another side, so you decide, okay, let's shift to another pin, to another analog pin. They say, okay, we change the sensor to, let's say, A5. Then you have to come on each sensor reading, you have to change, okay, you have to change this to A5, change this to A5. Can you imagine if you have like 100 places between you reading this sensor, okay? It will be very headache and pain in the ass if you really go and do this manually, okay? And again, if you have like different input outputs using multiple times, so it's better to use the text substitution. Text substitution, then you can just change it once, it will change for you in all the places you call it, okay? So now, if I change it, for example, sensor 3, after you done your design and you done your pre-design stage, then they ask you, okay, you need to change this or add more sensor, or this one maybe change from analog to digital or anything, then easy peasy, you can change from, okay, A0, A3, then everyone will be happy, even your compiler, very fast, okay? So this one, again, it will replace all the words with the same spelling, same, any word that's named sensor 3, it will be replaced with A3. LED motor is the same thing, okay? So I will use the same technique to replace the serial monitor, okay? So I will use the same technique to replace the serial monitor. How? By using this trick, very small trick. Hash define. I will call it debug of message. You see now, it mean, if you understand really this, it mean replace all the motor word inside the code with 4 or LED with 8. So I will replace the debug message with what? With serial dot print. And print what? Print the same message. Whatever message we are passing here, it will come to here. Okay? So now I define the serial dot print. Now I come to define serial dot print line. So I come to define debug line with the same message with the serial dot print line message. Okay, so with this I can replace now all the serial prints that I used it for debug before. For example, here this one data actually is not as not a debugging message, actually is my sensor data I want to present out. But for example, if you come here, this one, let's activate it again. This one actually is a debugging. Let's activate this also. Serial, this one for debugging. Okay, this is value, serial print group function. Okay, good. Okay, so now I will replace all the serial.print that I set it or wrote it for debug with this one. So serial.print will be changed to debug. Okay, this one, okay, this one again, serial.print will be debug. Digital serial, this one again, debug. This value, this one again is a debugging sensor. This one is not debugging actually. It's a data that I want to display or send it to somewhere using the ART or through the ART. serial.print, this one debugging. Wait, this second value, again, debug. Loop function finish, this is debug. Okay, sensor data. Okay. And now let's add more debugging messages. Say data read successfully. Okay, so now if we compile it, our compiler should be happy. Yes, you see now? Because I already asked it, okay, whenever you see debug with any message, you just replace with the serial.print or print line with that message, okay? So now if I remove this, it will scream on us to say, hey, what the debug name meaning here? Okay, I told you, it's okay, don't you worry, debug is mean serial.print, then it will be okay, thank you very much. But now again, we are not actually helping, or we are not actually reached to the point that is really helping. You see, still there's a lot of debug, and still if you want to deactivate one, we have to comment manually one by one. So how to solve this issue? Okay, solve this issue by conditioning this. We not keep it freely like this. We put some condition. Okay, using some condition. Before the condition will be related to a variable. We define again hash define debug mode. Okay, so according to this value that it's been held in the debug mode, then we can say whether it's for debug mode or the run mode. So if debug mode, but be careful here for the if, you cannot use a normal C coding if, because here actually we are the what they call the text substitution place or area, so we have to use a preprocessor if condition. It's always start with hash. Hash, if this one is true or equal to 1, then you do this. Okay, and if, again, starting with hash. Okay, so if this one 1, then you substitute with this. So if you run now, you see it's happy. But how if we turn it off? I don't want it. You see, because here is off. This one actually is called the pre-processing code. You see, it's execute this before even come to here. When execute this, you say, okay, this one 0, 0 has been false, false. It will not come to here. It will directly jump to the other one. I mean, go out of the condition. So it doesn't see what's inside the if condition. So it doesn't declare or remember that, okay, debug message is mean say.print. So it doesn't know when we turn it off. So we have to add another condition, else hash define this as nothing. Just by the mean of, hey, compiler, keep it empty. If you find this in my code and I turn off the debug mode, please just ignore it or just treat it as an empty line. Treat it as exactly is an empty line. Okay, you see here, it will treat it as an empty line. Okay, so let's try this. I will activate this first, and let's add some this one. Let's add debug line. Give some space here. This one also. We add line and then make it more readable. finish start debug. This is a debug. Debug this second. Okay, finish. Loop has been finished. Thank you. Okay, let's add another delay here. Delay. This delay just for fun, actually. 1, 2, 3, 4,000. Okay, so let's compile our code and upload it to our Arduino. Oops. Yeah. Actually, is debug, not BG. Debug, yes. Why like this? I guess when I copy it, I missed something. Sorry for that. Debug. Okay. Okay, good. So now debug is okay, and I already activated. Let's upload. Okay, it's uploading, and here we go. You see now? This is the FI. What is this? Is the FI? I should jot down somewhere that this is the FI. No, I guess this one, because of the seal is not really finished. Yeah, loop function, loop. Okay. You see now it's printing my this, what they call debugging text. If I want to turn it off, easy, just change this mode to 0, no debugging mode, and upload. Okay, it's uploading. Happy, thank you. If you see now, wow, only my data that I want to really send it to the serial monitor, which is the data from my sensor, is 0, which is here. Okay, see, with one button only I can activate and deactivate my mode. And let's see actually our size, how much we can save. Let's take a new snap. So remember this one with 0, this is with 0. Let me jot down 0, no serial. Okay, now I will activate the serial. I will upload again. Okay, it's already uploaded. You see here, the serial debugging information is printed. And now let's compare the size. I believe that you will be shocked. Here we go. See, wow, this is the 0, 1. When I deactivate, I turn off the debugging. This one, when it's activated, about more than how much? About 4 to 500 bytes is being free up, okay, from the sketch memory or program memory. And for the variable, exactly 174 bytes it's been free up. Okay, 174. So can you imagine this different? And here actually we're not using much. It's just like how many? 1, 2, 3, 4, 5, 6 places only. 6 places plus maybe 2 here for the let's say 8 play to 10 debugging lines we are using. Can you imagine if you have a few thousand of code or using like few places here and there for debugging, then you have to forget which one is for debug, which one for this is a true data that I really want to send it to the serial. So with this code, with this small trick, we can control the debug mode and the run mode. It's very small and very useful trick, exactly, seriously useful. So that's why I love to share with you guys, especially for the beginners who don't be aware about this thing. Okay, you see now it's already in the debug mode, so I can turn off. Let's say now I finish my debugging mode, all the things are correct, my data satisfied, happy, everything okay. Now I wanna change to run mode and send to my client. Then I just change this to 0 and upload again. Voila, magic. Okay, so everything will be organized for you, everything will be removed, all the comments, debugging comments will be removed, and your code, the output of code will be very clean and very fast and very small size. Okay. So thank you very much. We have reached to the end of the tutorial today. This is the end, so I hope you have learned something from this tutorial. Actually, this is not a new technique or very novel. Actually, it is there in the coding rules or the coding, let's say, I mean, the people who already done the coding, they know about this, but I would like to share with you just for, especially for the beginner who are not really aware about this. And I want to show you then the things that what you can do actually to help you improve your coding techniques. So thank you very much, and I hope you have learned again something from this tutorial, and I will see you soon in the newer tutorials. Thank you.